Yes, good morning to you all. My name is Sumanta Sarkel. So on behalf of local organizing committee, I welcome you in the 40th annual meeting of the Astronomical Society of India, ASI 2022, which is being jointly organized by IIT Roorkee and ARIS Nainital. So this year, 2022 is very special for many reasons. We are meeting in person after 2 long years, and I hope we'll be doing so from now. So this year is the 50th anniversary of the constitutions of the ASI. In addition, IIT Roorkee is celebrating 175 years of establishment, and our country is celebrating 75 years of independence. So let us make this event a very successful one. And I again welcome all the participants and wish you a very nice day in our campus. So now may I request Professor Vijaya, Secretary of ASI, to deliver the welcome address. Over to you, Professor Vijaya.
Thank you so much. So, Honorable Professor Vijaya, Principal Scientific Advisor to the Government of India, Professor Rajiv Chakravarti, Director of the Indian Institute of Technology, Roorkee, Professor Deepankar Banerjee, Director of the Aryabhatta Research Institute for Observational Sciences, also known as ARIS, Professor G.C. Anupama, President of the Astronomical Society of India, Professor Devendra Ojha, the Chair of the Scientific Organization Committee, Deans and Head of Department of Physics of the Indian Institute of Roorkee. Esteemed colleagues and dear friends, it's my pleasure to welcome you all to the 40th annual meeting of the Astronomical Society of India, being hosted at the beautiful campus of IIT Roorkee, jointly with ARIS. Like Professor Sumanta just said, we missed past few opportunities to meet, and it's about after 2 years that we are meeting. And there were various uncertainties which we needed to deal with and you needed to bear as we planned this meeting. And I'm glad it has all finally worked out. I'd like to share that this is the largest ever gathering of the ASI with 716 registered participants. I'm also particularly pleased that we have a very young gathering. About half of our participants are PhD students. And if you include the postdocs and also the bachelor's and master's students who are presenting here, the number grows to about 70%. Right? So our ability to attract young people from our community to engage with them or to get them to engage with the ASI bodes really well for the future of the Astronomical Society of India. Our last meeting was the very first one to be organized completely online, and this one is the first to be organized in a hybrid mode. Only about 1/3 of the delegates are here in person, and the others will be joining us remotely. And when we started, it was grudgingly that we accepted the option of a hybrid meeting. It was the only practical means to accommodate the large number of delegates who wanted to be a part of this meeting. But it does bring us the advantage that it enables participation transcending the usual geographic barriers. Given that most of the participants will be joining remotely, the planning and logistics have been organized with that in mind. For practically all of us in the room here, this is the first meeting with a large in-person component which we are attending after the pandemic. The excitement and the happiness on the faces of delegates is self-evident. I'm very happy to be a part of it, and it feels very nice to talk about the pandemic in the past tense. The SOC has put together a very exciting and a rather packed program, and you will shortly hear about it from the chair of the SOC. And like Professor Sumanta already said, it's a very special year for us. We are celebrating the golden jubilee of the ASI. It's also a very happy coincidence that it is the 175th year of our host institution, IIT Roorkee. We also feel very honored and very thankful to Professor Vijaya, the Principal Scientific Advisor to the Government of India, for agreeing to deliver the inaugural address for our 40th meeting. I'll offer only a brief introduction for him. Professor Vijaya is a chemical engineering graduate from IIT Kanpur. He completed his doctoral work in 1983 from the Tata Institute of Fundamental Research in the field of molecular biology. After that, he spent about 4 years at the California Institute of Technology before returning to the Tata Institute of Fundamental Research in 1988. He was instrumental in establishing the National Center for Biological Sciences, NCBS, in Bangalore, under the aegis of TIFR in 1992. On academic fronts, he has spearheaded groundbreaking research to understand the important principles and mechanisms that control the nervous system and muscles during development, and how these neuromuscular systems direct specific locomotor behaviors. He was the director of the NCBS, where he continues as a distinguished professor. He's also served as the secretary to the Department of Biotechnology, Government of India between 2013 and 2018. And since then, he has been serving as the principal scientific advisor to the Government of India. He is the recipient of numerous awards and accolades. I list only a handful of them. He was honored by the Bhatnagar Award in 1988, the Infosys Prize for the Life Sciences category in 2009, and the Padma Shri in 2013. With no further delay, I invite Professor Vijaya to deliver his inaugural address, and request all of you to join me in welcoming him.
Thank you very much, Professor Oberoi, Professor Anupama, Professor Devendra Ojha, Professor Ajit Chaturvedi, Professor Dipankar Banerjee, and others. It's a great pleasure and an honor to be here today at the ASI function. My job is to give an address for which I'm not particularly competent at all. So you will please excuse me, but I will try to stress the importance of astronomy and astrophysics in a data-driven age, and how, while we have major efforts going on in the country, it is important for us to broaden the base of astronomy, and that's something which you're doing so well, and that's something which also needs to be scaled up nevertheless. If you look at the major efforts we have done in astronomy, these range from the ARIES, the Aryabhatta Research Institute, the Hanley Telescope, the Indian Institute of Astrophysics and its telescope in Kavalur, and other places, including Hanley. We have, of course, in different parts of the spectrum, the giant meter wave radio telescope, the radio telescope in Ooty, and so on. In other words, India has a great distributed set of astronomy and astrophysics observational telescopes. To this, I would like to add that something else is happening now to broaden this base and democratize access to astronomy and astrophysics data is led by the Indian Institute of Astrophysics. The government is setting up a major center for students, undergraduate students and school students, so that they can learn to observe and learn to analyze data and astronomy. This will also include a major planetarium in Mysore, adjacent to Mysore University. This venture, led by the Indian Institute of Astrophysics, will allow students to access sometimes live, sometimes archived data from telescopes all over the world, and then become experts in both astronomy and astrophysics on one hand and handling data on the other, and therefore make them ready for the world which awaits them outside. Today, I will rather briefly, and you will forgive me if it's a bit hurried, summarize where we are going in this situation regarding data and its handling going forward. There is a view that somehow, and this is not, I'm not talking about astronomy and astrophysics, in general, there's a view that the collection of data and its study is sufficient, and therefore one doesn't particularly need to have deep domain knowledge. The tools of artificial intelligence, machine learning, deep learning, and so on, combined with the development of artificial intelligence in the narrow sense, soon happening in the general sense is the view, will transform the world, and domain understanding is the implied notion that somehow that's incidental. Nothing could be further from the truth. Now, if you look at the history of astronomy in India, and we'll come to that in relation to big data and its analysis, we know that India has a great history, right from Aryabhatta 476 to 550 AD. And we knew at that time that the sun gives light and other bodies, such as the planets and the moon, are bright because they reflect light from the sun. And this suggests that, this led to the view that if there is light and there are objects, there should be shadows and therefore eclipse. This kind of study went on both in multiple ways, but also much later with Bhaskara, 600 to 680, not to be confused with Bhaskaracharya, who was also a poet, did much to popularize the views of Aryabhatta by writing beautiful verses. So there's a knowledge about that, including people like Haridatta, 680, in his Grahakara Nibandhana, and Govinda Swamin around 880. And later, much later, in Kerala, you have the Madhava and Sangamagrama study of mathematics in about 1340 to 1425. Now, this is the tradition, and it's important to know this, not because we must look backwards, but going forward, we must really have a rootedness in being daring, just as these people were, and be inspired by them and others all over the world to take on big problems. Our modern tradition in astronomy is path-breaking. We have the giant meter wave radio telescope, as I said, in Pune, telescopes in Kodaikanal, Udagamandalam, Gurushikar, Nainital, Hanle, and ISRO also has an astronomical satellite called AstroSat orbiting the Earth, and is about to launch another one, Aditya, to reach the sun, to research the sun, sorry. India is therefore, a leading astronomy researcher in the world. In these traditions, ancient and modern, that we must understand and take pride in. A desire for rigorous study going forward and a rigorous plan going forward for astronomy is what is needed. So I would urge the Astronomical Society of India to develop this forward-looking plan. Our office has worked with you and with several others for a forward-looking plan in what we call the mega sciences. Dr. Praveer Asthana, who has led that effort formerly at the DST, is here. And we have done this plan not just for astronomy and astrophysics, but also for nuclear physics, high energy physics in general, biodiversity, and so on and so forth. Once these plans are ready, then we'll be able to see how we can find the resources, the people, and the talent to take these forward. Now, let me come back to this point I mentioned about data. If we look at the world about 30 years from now, we would see something which what I call historians of the future are warning us now. And they say that there are dark paths which we've taken in the understanding and use of data, which could polarize the world greatly. They say that power and the ability to handle data will be concentrated in the hands of a few, and therefore everyone else will be told what to do and what not to do, perhaps for their good, but this will be in some kind of a disempowerment. Where does astronomy and astrophysics come in over here in this debate? Well, let's look at the broader point about artificial intelligence, machine learning, and so on, and how the collection of that kind of data is impacting every field. So that's going to be a general theme, and how it can impact astronomy and astrophysics in particular. Now, across the world, large corporations and governments collect data, distill it, and use the information and knowledge for making decisions. This has been going on for thousands of years. Even before these corporations, other people have been looking and collecting data. So today, these corporations and governments and other agencies do it fast, and they perhaps also do it well. They do it comprehensively. Knowledge has always been the key that opens the door to power through millennia, but today fewer and fewer share that key. Yet the lives of more and more than ever before will be impacted by those who have the key. Even more interestingly, the master key, some say, may not be with humans anymore. So let us wake up from this prediction, this dire prediction, which some, again, what I call historians of the future say, and ask whether this is correct or not. How far into the future can we see? How far can these historians see? And how ominous are the outcomes? This is a messy topic, and the answers are also perhaps much more complex. Now let's look at the promises and perils of the churning of data in this manner. And astronomy is one of the biggest churners of data. Now, if you look at data, computing, and AI through history, through science and society, we find that this has its origins, what we're doing today, in some ways in a question which Alan Turing asked in 1950. Turing asked, can machines think? And this was a paper published in Computing, Machinery, and Intelligence in 1950. And it's a very simple paper with very few references and something which all of us must need and encourage us to do that. A result of this paper was a Turing test which established the fundamental goal and vision of artificial intelligence. Now, if you answer Turing in the affirmative to his question, can machines think? Then you can ask, what is AI? And AI, as others have pointed out succinctly, it aims to simulate human intelligence or replicate it in machines. Now, Stuart Russell and Peter Norvig define AI as a study of agents that receive percepts from the environment and perform actions. Now, in this context, if you ask what is artificial intelligence, then they would say it's thinking humanly, thinking rationally, acting humanly, and acting rationally. And the question is, can machines do this on scale? Now, if you go out of your campus now, or to go to campuses such as IIT Roorkee elsewhere, you will find extraordinary examples of what nature does in terms of narrow artificial intelligence in some ways. So you look at a large termite hill, for example, it's exquisitely made. It seems as if it's something which is done with intelligence. It's got an extraordinary internal air conditioning system, and each termite works to its task and get it done. But there is actually no comprehension in this construction. There is competence, and that competence too is at a very local level and not a big level. The entire structure is an emerging property of local interactions in multiple ways. This kind of a structure can be imitated or simulated, even though it's still difficult, to a greater and greater extent by narrow AI. So the point is, narrow AI is often focused on performing a single task extremely well. And while machines that do it may seem intelligent, they are operating under far more constraints and limitations than even the most basic human intelligence. So narrow AI is all around us, as I said, and you can see this in many aspects of machines, but you can also see it in action in the way nature has evolved and how evolution has used these kinds of algorithms, as it were, to create extraordinary forms. Now, general AI is a much bigger task, and that's something I'll come to. But narrow AI is powered by breakthroughs in machine learning and deep learning. And understanding the difference between artificial intelligence, machine learning, and deep learning can be confusing. There's a nice book by venture capitalist Mark Chen, who provides a good overview of how to distinguishing them, noting that artificial intelligence is a set of algorithms and intelligence to try to mimic human intelligence. And I would say natural selection through evolution in biology also is a set of algorithms to create new forms. And machine learning is one of these tools, and deep learning is one of the machine learning techniques. Simply put, machine learning feeds a computer data and uses statistical techniques to help it learn how to get progressively better at doing a task without ever having been specifically programmed for that task, eliminating the need for millions of lines of written code. And machine learning consists of both supervised learning using labeled data sets and unsupervised learning using unlabeled data sets. Now, deep learning is the type of machine learning that runs inputs through a biologically inspired neural network architecture. The neural networks contain a number of hidden layers on which the data is processed, allowing the machine to go deep in its learning, making connections and weighting inputs for the best results. Now, much of all of this is something which we are using more and more in every part of science, material science, chemistry, drug discovery, and of course in astronomy. Now, there are two schools of astronomers, I understand, those who say that this is not particularly necessary, and those who swear by this, and we'll see how this evolves. Now, artificial general intelligence, which is the focus of many dystopian science fiction stories, is something which experts more or less agree that is not something which we need to worry about very soon, but the landscape is changing rather rapidly. Now, in this context, let me give you an example. And you all know about Jocelyn Bell Burnell's discovery of pulsars, where it's an example of how information is necessary for knowledge, but not sufficient, and how knowledge is necessary for understanding, but not sufficient. And understanding is necessary for reasoned action. And that's the reasoned leap which Jocelyn Bell made in her work. And it's very easy to see how such leaps are taken in hindsight, but it's also easy to see in that context how they need not have been taken. In other words, these are the kinds of leaps which human intelligence is able to do, and our interactions with machines and big data, it remains to be seen how we can do this kind of leaps, which are so important in advancing our work. Now, raw data, which we analyze, come from a huge variety of sources around us, from transport, from health, from agriculture, from observational astronomy, but also we create a huge amount of data, such as in places like CERN, through our experiments. Now, this kind of a data and its analysis is not possible without having deep domain knowledge in each of these areas, which ensure that the analysis, the understanding and use of this data confines itself to the laws of physics and of our surroundings at different scale. Otherwise, you get solutions to problems which match the data but are not physically feasible. Now, there are again tools which allow us to ensure that this takes place. So computers are getting better and better at learning domains also, but we still have a great need of using this in our locations in human context for two reasons. One, exciting new discoveries can still be made by human interventions and not by machines alone, but also our learning from each area is invaluable in another area. So I'll end by saying, how did it come about that humans have developed this capability to create such machines, and where do we go from here? Now, if you go to the Indian Statistical Institute in Kolkata, a center for big data analysis, you will find a reconstructed fossil of a dinosaur, Barapasaurus tagori, named after Rabindranath Tagore, discovered by Pamela Robinson. This dinosaur is an example of what dominated the Earth 65 million years ago, and how something astronomical, an asteroid, came crashing into Earth and destroyed many life forms. This resulted in the rise of the mammalian radiation after that. And in many ways, we owe our existence to astronomy. So I'd like to thank my fellow astronomers for engineering that. I'm just kidding, of course. Now, this analysis of what happened 65 million years ago, and indeed about 3 billion years ago on to now, and how life developed, was done beautifully by Charles Darwin and Albert Russel Wallace. And they showed that all life on Earth is connected by a shared chemistry. It has a shared origin, and that shared chemistry comes through the thread of DNA. And geneticists understood how DNA encodes components which make up the cell, and how the structure of DNA explains many aspects of how this takes place. Now, how did this come about in biological terms, that we wield such power to engineer nature? That came about by three accidents of evolution: our ability to oppose thumb and forefinger and make tools and throw objects and shape objects and engineer the land and space around us. The second is our ability to speak, changes in our voice box and corresponding parts of the brain. And the third, and these are not in the same, in any order, is the dramatic increase in the size of our brain, disproportionate to our body size and disproportionate to what other non-human primates have. So this ability of the brain to grow has transformed us from survivors on this planet to wielders of the paintbrush on the canvas of Earth, as Dan Dennett says. As he says in his book, Dan Dennett is a neurophilosopher, he says, Over billions of years on a unique sphere, chance has painted a thin covering of life, complex, improbable, wonderful, and fragile. Suddenly, we humans have grown in population, technology, and intelligence to a point of terrible power. We now wield the paintbrush. How did we grow in intelligence? Not by biological terms at all, but by using language and our ability to make tools to greatly amplify cultural evolution. Now, this has had an impact on Earth in a manner which is enormous, which is what we call the Anthropocene Epoch, where human footprints are there all over the world. And there are multiple landmark events which people say mark the start of the Anthropocene. One is the domestication of plants and animals about 10,000 years ago, increasing to such an extent now that we have the bones of chickens all over the place. And that is a landmark of the Anthropocene. The other is the Trinity site in New Mexico on July 16, 1945. That's 5 hours, 29 minutes, 21 seconds, and 16 milliseconds then after the one proposed start of the Anthropocene. So that's the A bomb. The next is the ability to capture nitrogen from the air and make ammonia, and then thereby make fertilizers. And sadly, that also led to the development of chemical weapons. But today, the ability to make ammonia and fertilizers has transformed agriculture, and the ability to hold populations much larger than otherwise could have been done. And today, we have about half the nitrogen in our body coming from the Haber-Bosch process. Now, let me conclude by saying that over the 4 industrial revolutions, beginning in the late 19th century, early 20th century on, there has been an approach of humans to harness nature, tame it for their benefit. This involves extracting ores from the ground, extracting energy, and building factories, having workforces which work for the owners of these factories, and finding markets all over the world. This method results in a high standard of living and a lowering of entropy in some communities at the cost of a massive increase in entropy in communities outside. And this today, as we go past the 4th industrial revolution, is not a sustainable manner. Today, we need to have energy from sources which do not damage the planet. That's a very big challenge. And that's a topic for another discussion. I won't go into that. We need to be able to use these energy and have the development of these sources of energy in a manner which don't destroy our biodiversity and don't have toxic components going into the planet. We need to have sustainable living. We need to, in contradiction to the wide use of energy, no matter what, we need to have sustainable development, which will require the huge use of energy. Therefore, that energy has to be used again in sustainable, renewable manner. And finally, we need to address issues of our large cities in a manner where they are livable, the quality of life is good. And at the same time, putting all this together, we need to take care of the future of the planet. This seems impossible to do, but this is the task, whether you're an astronomer or a cell biologist or a nanotechnologist or an algebraic geometer. These are the things which we need to attend to as scientists, each in our own way. And we can do that. How can we do that? Alan Turing, who wrote his 1950 paper, which was the precursor of what later came on to develop into artificial intelligence, said again in 1950 that we can see only a short distance ahead, but we can see plenty that needs to be done. And we must therefore be inspired by him and by Mahatma Gandhi, who said that the earth is enough for every person's need, but not for every person's greed. Combining these two, deep science, deep understanding of astronomy and astrophysics, the ability to handle big data, has applications not only in understanding the universe, but in making sure that we as stewards of the planet do well. Thank you very much.
bringing together a lot of seemingly disparate things and weaving them into a common thread, from democratization of astronomy by access to high quality data from observatories across the country, to the need for domain knowledge, even in this age of big data and AI ML, to be able to choose the most judicious and meaningful solutions, to develop a forward-looking plan while maintaining rootedness in scientific endeavors from the past, to understand and not necessarily be scared by the problems or the challenges which AI ML might pose for the world as we know now, the impact we humans are having on our home planet and the urgent need for sustainable development, and how even astronomers can contribute to this endeavor of not just progressing knowledge for the sake of progressing knowledge, but also making the world a better place. We thank you so much for the time which you gave us today. Many thanks from the Astronomical Society of India.
Thank you very much, Dr. Oberoi. Unfortunately, I have to run away now for another meeting, so may I be excused?
Thank you, sir. Thanks a lot, sir, for finding some time for us. Thanks a lot. Goodbye.
Thank you. Bye-bye.
Bye. Okay, so time to proceed next. May I now invite our dignitaries to please join me on the stage. Professor Chaturvedi, please, if you could join us on the stage. Professor Dipankar Bhattacharya, yeah. Professor Anupama, yeah. And Professor Oja, yeah. If you could please join us all on the stage. Thank you so much. So I now invite Professor Rajiv Chaturvedi, Director IIT Roorkee, to say a few words.
On behalf of IIT Roorkee, let me welcome all the delegates of this 40th meeting of ASI, Astronomical Society of India. I also understand that this is the golden jubilee year of the establishment of the society. So we are extremely delighted that on such a historical occasion, ASI is being held at IIT Roorkee. And as some of you would have noticed, this year is also very special for us. We are celebrating our 175th year. And the confluence of these two things hopefully has brought ASI to our campus. I must thank all the office bearers of Astronomical Society of India, in particular Professor Dipankar Banerjee and other office bearers for having finally chosen as IIT Roorkee for this event. We always look forward to welcoming guests for holding academic events. And the reason for that is not very far-fetched. As some of you may be knowing, IIT Roorkee is a very large IIT. It is having 23 departments. It is having 3 academic centers. It is having 1 school. And there are more than 9,000 students now who are pursuing various academic programs at IIT Roorkee. The number of faculty at IIT Roorkee is now 510. And what this means is that we have people who have interest in very different walks of life, academic pursuits. And astronomy is something so central to human existence, to the existence of the universe, that many students, many student clubs, many academic programs are either directly interested in astronomy or indirectly interested. In fact, just last week I was witness to this endeavor by our students the Physics and Astronomy Club of IIT. I don't know whether they are here or not. They produced a very interesting piece of collection of articles written by them in the form of the inaugural newsletter. And they were all very thought-provoking scientific essays written in very simple language so that anybody with elementary science can relate to them, understand them. And of course, the objective was to excite them, bring more people to those kinds of interesting problems that astronomy has to offer. So I'm sure that with the coming of the delegates and the event happening hybrid, many people in the campus would be enjoying, would be watching whatever the topics that are of interest to them. I hope that your stay in the campus will be pleasant. If you face any problem, please do not hesitate in reaching out to Professor Sumanta Sarkar. He's our local point of contact for this conference. While at Roorkee, I mean, there are so many things to see, so many things to experience inside the campus, outside the campus. So let me talk about a couple of things inside the campus. So just if you walk across a few meters, you will come to the Mahatma Gandhi Central Library that houses a very interesting institute archives. And in this institute archives, you will see very rare books, manuscripts, including the first copy of the Constitution of India, including the first folio of Shakespeare's Macbeth, many such interesting things in terms of equipment and also documents. It is a place worth spending at least an hour or two. There is another interesting place in the campus. This is the Medlicott Museum. This Medlicott Museum is in our Department of Earth Sciences, and it houses both, fossils as well as stones, which have importance in terms of geology and in terms of their age regarding millions of years and the kinds of things that we see in terms of thigh bone of an elephant or a backbone of a whale, and which date back to several million years ago. So if you get time from the busy schedule, do visit those places. And of course, if you stay here till 28th, Professor Banerjee and his team have arranged a dinner at my lodge. So you are welcome for the dinner also. And with these words, I wish that the deliberations are very interesting, very thought-provoking, and very involved. Wish you all the best.
Thank you so much, Professor Chaturvedi. I now invite Dr. Dipankar Banerjee, Director Aries, to address the gathering.
Good morning. I'm actually waiting to hear good morning feedback from the audience also, because we are missing this for the last 2 years. So I think it's a privilege for me to welcome you on behalf of the local organizing committee as a co-chair. I'm missing my other co-chair, Dr. Armugam, who had to travel to Germany. First of all, really thanks to Professor Chaturvedi for giving us this opportunity. It's been such a pleasure to work with your colleagues from the physics department for this meeting. We had lots of uncertainties whether we could have an online meeting or a hybrid meeting. Until 3 weeks back, we were not sure we would be able to meet in person. But thanks to all the volunteers, I'm really again thankful to all the volunteers from the physics department and from Aries who've been able to put through this program in a short period of time. So I'm looking forward to this meeting. As a society, I think my colleague Professor Ojha will allude about the details of the programs what we have. So these are annual meeting, just not for science, but for social interaction as well. So normally we keep provisions of different activities, community responsibilities, gender equity. We talk about career opportunities, so these kind of interactions beyond the scientific rigorous sessions makes these events as, unusual or really special. So I'm very happy, a lot of youngsters are there. In fact, we were discussing probably some of the seniors, we are not taking enough responsibility and we should attend these in-person meetings more. I know current circumstances, still there are a lot of hesitation. And I'm hoping that, in near future, we'll be able to, even the seniors will be able to participate in even more actively. So again, on behalf of the local organizing committee and my colleagues from Shumanto and his friends from the physics department, I welcome you all. Please do enjoy the meeting and participate as much as possible. And please give us your feedback also so that we can make these kind of events in future, in a better way. Thank you again. Thank you, Professor Vijaya. Yeah.
Thank you, Professor Banerjee. I now invite Professor Deven Gojha to tell us a bit more about the scientific program of the meeting. He's the chair of our SOC.
So very good morning to all of you. So I thank ASI Secretary for inviting me to speak about SOC activities. So first of all, on behalf of the Scientific Organizing Committee, I welcome all of you for this 40th annual meeting of Astronomical Society of India, which is being held at IIT Roorkee. And this is also a special occasion, which is already mentioned for us since the ASI is completing 50 years of existence in this year. And ASI, of course, has planned to have a series of events to celebrate this landmark, to deliberate and organize various activities during this year. So apart from regular sessions, the SOC has also planned to schedule 3 special sessions during ASI 2022 to celebrate these 50 years of existence of ASI. So we will have a public lecture on Sunday, 27th morning, evening, and then a special plenary session on 50 years of Astronomical Society of India is scheduled on Monday, 28th March morning. And there is another special session on first time we have actually introduced it called Industry Academia Interface Meeting, which is scheduled on the last day of the meeting. So I request all of you to please attend these very special events which has been organized to celebrate this ASI 50. As you will find, apart from the regular scientific program, which spreads over 4 days in 24 sessions and covers a magnitude of current existing topics, exciting topics from our sun to extragalactic astronomy and so on. Although you will find that the program is very packed this year because we have to introduce many special sessions, but there are exciting lectures covering a wide range of topics if you go around the scientific program. So apart from regular sessions, you will also find few other special sessions. Of course, thesis presentation is a regular feature, but this time we have a record number of thesis presentation, actually in a total of 17 presentations. So we see that a lot of good quality PhD theses which are coming up, and this is a record number for this year. Then we have a session for Public Outreach and Education Committee, which is a parallel session. Then also we have a special session on Working Group for Gender Equity. And also the first time a new initiative has been started to interface between astronomers and planetariums. So there is a parallel session on activities of planetariums during this ASI 2022. And also not to forget that there will be a short presentation from very young student on cosmic warfare during this ASI 2022. So now I would like to give you share some statistics with you. So as ASI Secretary has mentioned that we have more than 700 ASI participants this year. And among them, actually 34% participants are female participants, which is almost a similar number which we have seen past 2 years. But however, it is really good to see a very young population this year, more than 70%, which Professor Oberoi has already pointed out. We have 62% students who are PhD and master's student and 9% postdoc. So this is good to see that young population which is attending ASI. So ASI has this year selected almost 150 talks and 360 poster presentations. These include public lectures and special lectures. and which means that about 72% participants are actually presenting their work during ASI meeting, which is really good thing to see. And there are about 40% female speakers, and I see there is some improvement since past 2 years in the female participants in the talks in the ASI. One thing which we may perhaps to improve, which of course we pointed out last time also, is the induction of new ASI members. So I see only 25% ASI members are actually attending ASI meeting. I think I encourage all young participants to become ASI member, and it is a good opportunity during this ASI meeting. So finally, I would like to thank all the SOC members for their valuable inputs and help in organizing the scientific programs. As I understand, a new AOC will take charge after this ASI meeting. So I especially thank all the outgoing SOC members for their time and help in organizing the ASI scientific activities during the past 3 years. I would also like to thank all the speakers who agreed to present their work during this ASI meeting. A special thanks to our public and planning talk speakers who could spare their time and agreed to give their talks. And thanks to all chairperson and judges who will really help us during the ASI meeting as we go along with the scientific programs. I also thank ASI President and ASI Secretary for their constant help, and not to forget thanks to Padmasri from the ASI Secretary Office for her suggestion throughout the process of finalizing the ASI schedule. And finally, thank to LOC for all their hard work and support for organizing this meeting. And I hope this will be an exciting and fruitful meeting. And I request all of you for your active participation during this ASI meeting. Thank you very much.
Many thanks, Professor Ojha. I now invite Professor G.C. Anupama, President of the Astronomical Society of India, to deliver her presidential address.
Morning, everybody. I decided to keep the title of my presentation as just presidential address. And it's my privilege to be standing here giving the president's address in the 50th year of the Astronomical Society of India. And I'll be handing over the reins of the society to Professor Banerjee and his team, who will have the privilege to take over the reins of the society in this memorable year. So let me start off with a brief introduction to the society, since we have a lot of young members here in the audience. And also, hopefully by the end of my talk, you'll all be enthused to become members of the society. So ASI was formed in 1972, in November 1972, with the objective to promote astronomy and related areas in the country. So the main functions are to encourage the study of all aspects of astronomy and astrophysics, to hold scientific meetings for presentation of the scientific results and to publish journals, to popularize the science of astronomy in the country amongst the educational institutions and public at large, and also to express the views of the astronomy community in the country regarding the current status and the future developments of, for the field of astronomy. In addition, the motive was also to keep a liaison, the ASI should be the liaising society with other societies in the world, institute lectures, prizes, and fellowship, encourage coordinated research programs among Indian astronomers, and to initiate and perform any other activity and functions which would advance astronomy and related sciences in the country. So the society began with a small number of 80 to 100, and today it has grown to about 750 regular members. We also have associate members, students, and institutional members. And what I show here is the growth of the society in the past 9 years. As you can see, we have been having on an average of about 35 to 40 people joining. We certainly need to increase that number. The society has been very active in its scientific activities, in the outreach and education. And we are also very conscious about the gender equity and diversity aspects in the community. And moving on with the times, the activities of the society have gone digital, and this is increasing. As already mentioned by Divya, even during the pandemic, we managed to hold the annual meeting, and it was completely online and a huge success. And today we are holding a hybrid meeting. So the annual meetings of the society itself have been held across the country. And we have taken, this way we have taken the excitement of the astronomy in the country all over. Here are just some pictures of the various meetings we have had in several parts of the country. ASI had been publishing the journal, the Bulletin of the Astronomical Society of India, and this was published until 2015. In the meantime, in the early 80s, the Indian Academy started publishing the Journal of Astrophysics and Astronomy, and both these journals were running in parallel for several years. When finally we decided that these two journals could merge together, and today we published the joint the joint publication of the Journal of Astrophysics and Astronomy. Since 2017, it is jointly published by the ASI and the Indian Academy of Sciences. ASI used to support schools and workshops in the past. However, in the recent years, this has not happened, and we should begin this activity again. The first meeting was held in 1974 after it was formed in Osmania University. In fact, the beginnings of the society is from the Osmania University in Hyderabad. The format of the scientific sessions have evolved with time. Today we have theme-based plenary sessions and parallel sessions, which include invited talks, oral presentations, and poster contributions. And we make efforts to maintain a good balance of gender and age in the invited talks and oral contributions. Public outreach has been another important activity. In the initial years, this was handled by a single scientist who was called the public outreach scientist in the society. In the year 2014, a committee was formed, the Public Outreach and Education Committee, and since then, the activities of the ASI in this area has increased dramatically. The activities have a pan-India approach, and efforts are made to involve local organizations like schools, colleges, the amateur associations, and the planetaria, the local organizations, to be a part of our outreach activities. ASI POEC has a very strong social media presence through its Twitter and Facebook accounts, and also its YouTube channel. And we have seen, this presence has helped us a great deal, particularly during the pandemic time. We used the opportunity to go online full force, and the POEC has been organizing monthly webinar series called Astro Edda. And they've also been holding talks by several scientists. And this is called the Ask an Astronomer series. These are hugely popular, as one can see from the number of people participating and viewing these programs. So I very strongly encourage the younger members of the society to participate very actively in the POEC activity. So the committee also has what are called as the associates of the POEC who can get involved with the various activities of the POEC. In 2015, a working group for gender equity was constituted. And this working group maintains the statistics of women astronomers in the country, tracking their career profile, and we maintain statistics about how many are there in the student level and how many actually move on to taking up, getting permanent positions in the various institutions. I must say that, although we have a lot of young women, almost 50% in the student community, it's a relatively smaller fraction who are there in the permanent positions, and this certainly needs to increase ability. And we do need to make special efforts to make this happen. The committee also organizes gender sensitization lectures in various institutions across the country. And they hold special sessions during the Astronomical Society of India meeting. So I urge all of you to attend them. This committee also collaborates with similar groups in other associations like the Indian Physics Association, the International Astronomical Union, and the International Union for Applied Physics. It also coordinates with the local organizing committees of the various ASI meetings that we have, and so that we can organize childcare facility for the early research, early career researchers who want to participate in the meetings. And this, I think, has helped in increasing the participation of the ECRs in our ASI meeting. So let me now touch upon the current status and future development of astronomy in India and how ASI has been contributing to this. As mentioned by the PSA in his address, there is this activity for developing a mega science division document, which we abbreviate to MSU 2035. This has been initiated by the PSA's office. There are going to be vision documents in 6 different areas: in nuclear physics, high energy physics, astronomy and astrophysics, accelerator-based science and technology, climate research and ecology, and environmental science. It is the first time that astronomy and astrophysics is featuring in such a mega science vision document activity. And in my address last year, I had talked about the need for such a vision document and what was expected out of such a document. So since then, we have actually completed drafting this document. Now, although this was an activity which was initiated by the Office of the PSA, the ASI has played a major role in facilitating community participation in the drafting of this document. The entire document has been driven by community participation, and that was the aim of the drafting committee right from the beginning, that this should be the voice of the astronomical community in the country. So what we did was a questionnaire was circulated to all the ASI members and also within the various participating institutions and departments. Based on the inputs that we received from the members, as well as we also looked into the various other documents, such as the decadal vision documents of various countries, like the European one and the US Astro 2020 decadal document. We also looked at the various proposals that we have submitted for participation in the mega science projects. Taking inputs from all these documents, the MSV 2035 vision document has been drafted. And it has already been shared with all the members of the society, and we have got inputs from several members, and these suggestions are now being incorporated in this document. So what does this contain? So first is, of course, the science. So this contains the leading astrophysical questions that we would like to address in the coming decades. obviously covering a wide range of topics, because in India, astronomy and astrophysics is practiced across the entire, all the areas in astronomy and astrophysics. We also talk about the status of the global efforts in this area, and what is the current status of the national R&D, providing some science highlights, talking about the existing facilities, and providing some recommendation for optimizing the usage of the current facilities and increasing the science efficiencies. We also talk about the mega science projects, which is the main theme of this vision document. Provide a summary of the various projects that we are involved in or we would like to be involved in, giving the timeline of these projects, and give a priority and some recommendations for efficient project management. We've also addressed the strength of the community, what it is today, and how we should grow if we are to make an efficient use of the forthcoming facilities in the future. Now, astronomy has grown beyond what we knew a few decades back. And there's a lot of synergy with various other areas, particularly with the areas which were covered by these vision documents. So we also talk about the synergy in other areas, like in laboratory astrophysics, the laboratory plasma physics, like for instance, how our participation in programs like the FAIR and ITER can be useful for astronomy. Nuclear astrophysics, of course, we all know, and astrochemistry. And finally, we give some recommendations within the document. So let me quickly go over the key science areas and the leading questions that are included. We begin with the fundamental physics, wherein the astronomical observations are currently interpreted in the framework of the basic physics, being time and space independent. But there are also some theories which allow for space and time variance, which would obviously have a major impact on the understanding of the universe. And hence it is important to have observational verifications of some key points as to whether the fundamental physics interactions are universal and irrespective of, this happens irrespective of time and space. Whether gravity is a fundamental interaction or an emergent phenomena, and whether the physics that dominates the interactions at the supranuclear density expected in the center of neutral stars in the early universe, what this is. We all know that the universe is predominantly comprised of dark matter and energy. Although we know this, we still do not know the nature of the dark matter and dark energy, and what about the interaction between the dark matter and dark energy and its effect. So this is an extremely important area that we would like to address. In the early universe and cosmology, in India, this is a field which has been practiced for a very long time, and this includes the theoretical construction of models for inflation, working on theoretical ideas related to inflation, and confronting model of inflation with observations. The study of the cosmic wave background and the epoch of reionization, and the study of intergalactic medium. The observations of clusters, logical parameters, and more so in this area. So based on all the science that we're doing today, there are certain leading questions that one would like to address. The foremost being, what were the initial conditions of our universe and how did they originate? There are, and also to understand the epoch of reionization, not just theoretically, but observationally, which is already happening. And very recently, the Raman Research Institute has provided some fairly exciting results. Another interesting area is in understanding the generation of the supermassive black holes and the primordial black holes. So this brings us to the large scale structure of the universe, which is another area which has been predominantly theoretical in nature, but of late also taken the observational aspect. So the formation of the large scale structure of the universe and its evolution is extremely important. So coming from the large scale structures to the smaller scale, the formation and evolution of galaxies is very important, and what are the connection between the stars, gas, and the underlying dark matter distribution and their influence in the overall formation, evolution of the galaxies. And also what is the influence of the large scale environment on the properties of a galaxy. And then, of course, the area of active galactic nuclei is something which is very important for Indian astronomers who have been practicing this for a few decades now. Again, in both theoretical and observational side, there has been significant contribution. So this is another area that one is interested in pursuing, particularly in understanding what triggers the formation of active galactic nuclei phase in a galaxy, and also what controls the duty cycle. And understanding the AGN feedback in influencing the star formation and evolution of galaxies. We should not forget the study of our own galaxy, which has been the mainstay science, particularly from IAA. The main areas covered are the structure and the chemical evolution of the galaxy through the study of stellar abundances, and the study of stellar motions and composition of stars, the study of star formation history in the nearby galaxies, and the study of detailed morphology of nearby galaxies. So there are a lot of leading questions here, which includes understanding the dynamics of our own galaxy, as well as the star formation, the formation of planets, and the dark matter in our galaxy, and various such science areas. So I talked about the formation of stars and planets, another area with very significant contribution from Indian astronomers. Although this is an area which has been practiced for several years globally also, there still are a lot of, parameters that are still unknown in this field, and we expect to understand a lot more about star forming regions with the JWST, which can probe in the infrared beyond the ISM's capacity. So we will have a lot more observational information. So I already mentioned about the star formation, and there are several other leading questions in this area, which one would like to address, including understanding the stellar initial mass function at both the high mass end as well as the low mass end. And going into detail in the stellar abundances themselves, understanding the metallicity, and understanding the first stars and their formation through the study of metal poor stars in our own galaxy. And also understanding the various isotopic ratios of the heavy elements in stars and their implication on the chemical evolution of the galaxy, and the understanding the metallicity, the metal poor galaxies and their formation. So we have been contributing very significantly in several of these areas, and so we would like to pursue them further. Compact objects is another area which is of interest, particularly with the launch of the AstroSat, providing multi-wavelength observations simultaneously, this field has become even more exciting. Accretion physics around compact objects is another area which has been pursued, and a lot of interesting science coming out of it. And in the recent times, the gravitational wave events have brought the merger of compact objects, the science of the merger of compact objects into the forefront with multi-messenger observations. So this brings us to the time domain astronomy and the study of the transients. Now, this is an area of importance in the country, particularly since the last decade. And the longitudinal advantage that the Indian facilities provide in this area is something very unique. It provides a unique understanding of the time-dependent evolution of these transients. There is a significant international collaboration in this area of science, and this is an area of science which requires international collaboration so that one can use multiple facilities across the globe and get a near 24-hour observations of these transients. So there are several leading questions in this, understanding the progenitors of these transients like the supernovae, particularly the type 1a supernovae, what are their progenitors? The interest in the type 1a supernovae is in the use as distance indicators and using them to understand cosmology. GRBs are another interesting objects, and we know there's a connection between the GRBs and the supernovae. But why is it that only some GRBs also show supernovae and not all others is another interesting area. And of course, the binary, the compact binary mergers, which produce the heavy elements through the art process during the mergers. And in the era of the LSST, there'll be a lot of transients which are discovered. Many of them would be unknowns. So the study of these, understanding the nature of these progenitors, the transients and the progenitors will become an extremely important area of science. Another important area of science is the exoplanetary science, and this is an emerging area. In the country, the group doing this is still a relatively small group, and we are in a position to increase that. The current studies are, observationally driven through the transit observations of several exoplanets and the confirmation of exoplanets through high precision radial velocity measurements. There's also a significant amount of theoretical work going on, particularly in understanding the exoplanet atmospheres and simulating the spectra from the planet atmospheres, which will one can actually confirm this through the observations from JWST and the 30-meter telescope in the future. So some of the key questions that one would like to address are understanding the thermal and the chemical environments in the protoplanetary disks and how they influence the planet formation. The studies of the star-planet interaction, this is an extremely important aspect because this is what influences the habitability of planets. Defining the biosignatures and enabling the actual detection of biosignatures in exoplanet atmospheres and studying the exoplanet atmospheres themselves in great detail. Not to forget our own sun, the solar physics. This is one of the longest pursued disciplines in the country. This includes observations and modeling, understanding the solar activity, which is a long-term as well as the short-term activity using multi-wavelength observations from both ground and space-based observations. Studying helioseismology, and a new area in this solar physics is the space weather science and space weather forecasting. So there are several key questions in this area. And I'll just stress upon something which is becoming increasingly more important, and that is understanding the Sun-Earth interaction or space weather. This is becoming increasingly important because the activity on the Sun has a direct influence on several of our day-to-day activities, which are based on satellite communication. So this is something which is very important for us in the current era. The studies of solar system objects has been going on, but I would say in the present day it's somewhat on the low key, but it needs to become very important, particularly in the studies of the near Earth objects, the detection of potentially hazardous objects, and determining the trajectory and orbits is very important. And also in understanding the interstellar comets or the visitors, understanding their trajectory and tracing their origin. So these are some areas which would be of prime importance in the coming years. So some recommendations on the key science areas, which we believe is commensurate with what is seen globally also. These are in the areas of exoplanetary science, the time domain astronomy, gravitational wave astronomy, early universe, star formation, Milky Way structure and thermodynamics, solar activity and space weather, and the study of near Earth objects. So to do all this, you need facilities. And for that, you need, to address many of the science cases, we need large facilities, or what we call as a mega projects. Now, all of you know that what we have today is, we have, for example, in optical and IR, we have a suite of 1 to 2 meter class telescopes, and currently we have one 4 meter class 3.6 meter DOT, and very soon we'll have the 4 meter the liquid mirror telescope. So basically, we have a suite of 1 to 4 meter class telescopes in the country. We have a couple of solar observatories with very moderate facility. The GMRT is something that we can be extremely proud of. It is one of its kind facility across the globe at low radio frequencies. So I would say that barring the GMRT, we don't really have a very competitive, observing facility in the country. Of course, we have the AstroSat, India's first space mission, which provides observations across the X-ray and the ultraviolet regions. So if we compare with what we have globally, I'm particularly talking about the optical and IR. We know globally the space telescopes, and JWST has been just launched. It's a 6 meter telescope in space. HST is already there and functioning for more than 3 decades. In the future, the Nancy Grace Roman telescope will be launched, which is also going to be at L2, which is primarily a survey telescope. But what do we have in the country? We just have 1 to 4 meter class telescopes. So we are clearly lacking in having access to 8 to 10 meter class telescopes and doing competitive science. In the solar, there's been no major development for several decades. The 50 centimeter telescope in Udaipur is the largest we have, whereas globally, the 1.5 meter Gregor and the 2.4 meter DKIST are already available. So we are lagging quite a bit as far as our observing facilities are concerned. And this makes us very dependent upon data from other facilities, which is not a very happy situation. So we certainly need to improve our facilities. So in order for us to be competitive, we need to have access to multi-wavelength, multi-messenger, large facilities. Efforts have been going on towards this. And Majorly, India is today a partner in part of 3 international major projects. The 30-meter telescope, which is the optical IR telescope. Participation in the square kilometer array for the radio. And LIGO India, which is gravitational wave studies. So we need to also expand to the sub-millimeter region, which is extremely important for the areas of star formation. And there is a proposal to set up a 15-meter telescope in the Ladakh region. The high energy TV range is another area where we are just entering that with the MACE telescope, the major atmospheric Cherenkov telescope, which is coming up in Hanle and under commission. But it will also be very useful to participate in the international CTA collaboration. So these are some of the recommendations which have been included in the vision document. In addition, there are other recommendations. In the solar, we will very soon be having the space observatory Aditya L1, which will be launched in a year or so. And we certainly need a complementary ground-based facility while Aditya L1 is in function. And there's a 2-meter solar large telescope, the NLST, which has been proposed. Much of the groundwork has already been done. We have acquired the land for this by the side of Pangong Lake in a place called Meerut in Ladakh. And today the telescope design and the instrument design, everything is ready. So if we are funded, we can essentially have this telescope working in the next 5 years. So if this really happens, then it will be complementary with Aditya L1. And this is extremely important for the solar astronomy in the country. As I said earlier, the largest optical telescope will be the 4-meter plus telescope. And it's a huge jump between the 3.6 meter to the 30-meter telescope. So we certainly need to bridge this gap. And we need to have a national 10-meter class telescope. There is a proposal already in place for this. In addition to this, it is extremely important that we need to understand the existing facilities should not go obsolete. They have their own use and utility. So it's important to upgrade, automate, and network the existing facilities and make sure that these facilities also become part of a global network. And this sort of a network, which is not just within the country, but globally, is particularly important for transient astronomy. And as I said earlier, in the era of the LSST, there are going to be enormous number of transients which are going to be discovered every day. And the immediate follow-up is something which is very important, and that can be done only through global network of telescopes. India's location is very unique. We have a unique longitudinal advantage, and we need to cash on this. And we can do this only by having a network of telescopes which can be part of the global network. With AstroSat, we have demonstrated our capability in developing and successfully launching and operating space missions. So we need to go beyond AstroSat. Globally, there is no major UV mission planned, and this is a niche area that we should take advantage of. There is a proposal to have a 1-meter UV space telescope called the INSIS, and that should certainly come. Also, there is no broad range of X-ray mission, and particularly I'm talking about transients. And also, this is extremely important again in the era of LSST and gravitational wave astronomy. So there is also a proposal for that, and let's hope, and hopefully that will also take off. So in addition to the facilities, the observing facilities, there are other recommendations, particularly with respect to data. It is important to have a common data center which will bring in the data from all the various facilities. And we need to understand that with the large facilities, the volumes of data that we get are also going to be huge and very large. And in fact, even analyzing the data that you get out of these instruments will require very high computing power. So such high computing power is not just required for theoretical simulations and modeling, but in fact, even for the analysis of data themselves. So it is very important to have such a common computing facility and to also develop very smart programs, data pipeline programs, which will bring in new technology like artificial intelligence and various other new technology capabilities in software. We can no longer go with the older way of doing things. So it is extremely important to move forward in this direction. We need to build a community with expertise in astronomical instrumentation, because just building a telescope is not sufficient, or just having a few instruments when the telescope is built is not sufficient. We need to constantly keep upgrading ourselves with new instruments, incorporating new technology, and you will need to have new type of instruments as the science evolves. So this is another area that is very important. Obviously, for all this, we need to grow the community. We need to grow the human resources. So we have certain recommendations for an inclusive growth of the community. And what we feel is that we need to grow our community beyond the few traditional institutions that have been there. We need to grow in various organizations and have critical mass across the country. So as an example, for the 30-meter telescope, we had done this study. We said, typically telescopes of that kind have at least a factor of 6 oversubscription. And with our participation in the 30-meter telescope, we'll have approximately 25 nights per year. If you want to have a factor of 6 oversubscription number of proposals, you need at least 150 or so proposals in a cycle being submitted. And for that 150, not every astronomer is going to submit proposals. So let us say you need at least 3 times the number of astronomers for that. So for us to effectively use a 30-meter telescope, we need to have a population of 400 to 500 active astronomers in the country. We do have a lot of young people, as we can see from the participation. And we also need to ensure that a good fraction of these people get permanent positions and are able to carry out the science within the country. So this is the way we need to grow our community, and we need to take steps towards this. And more important, finally, is the dissemination of our scientific outcomes. Our scientific outcomes will be, by scientific outcomes, I don't just mean the research, but also the development aspect of the various science projects that we undertake. We need to transfer some of this to the society. There has got to be societal benefits. We need to communicate the joy of doing science, the excitement of the research, the results that we get to the community. This is an extremely important aspect. And so this is one of the recommendations that we have in the vision document. We also provide a priority of the projects. We have divided it into the large projects, which are higher than 500 crores, and into projects which are lower than the 500 crore amount. So our priority, and we also prioritize wavelength-wise, because obviously we want multi-wavelength, multi-messenger facilities. So the 30-meter telescope, where we already are partnering, is obviously something that we need to continue in. And we certainly need to have a 10-meter class telescope, the National Large Optical Telescope. The NLST is an extremely important facility that is required for the solar community, and that is of highest priority in the solar astronomy area. In the radio we are already participating in SKA, the phase 1 of SKA. In addition, we need to enhance the capabilities of the GMRT so that the GMRT can actually become a part of the global interferometric network in radio. And we should also look into participating in SKA phase 2 whenever that begins. Multi-messenger, gravitational wave, obviously, there's a lot of work going on setting up LIGO India, and that certainly needs to be supported and continue. A new area where we currently don't have a presence, the submillimeter area. We certainly need to get into that. We have excellent sites in the country, in the Ladakh region, and we need to take advantage of that. So in the category below 500 crores, we certainly say participation in the international 8 to 10 meter class observatories is of prime importance. Even while we are waiting for having our own 10 meter telescope or the 30 meter telescope, it is very important for us to begin getting data from the 8 to 10 meter class telescope. As I mentioned earlier, the network of telescopes. And there are smaller projects, international in nature, where we have a small presence. It's good to continue in that. In the gamma ray, I already talked about our participation in CTA. CTA phase 1 is currently going on. We should look at participating in the phase 2, which will begin in 3 to 4 years down the line. So for the sake of completeness, let me also talk about the future space missions as provided in ISRO's vision document for future space missions in astronomy and astrophysics. The ExoWorld is a space mission. It's a 2 meter class telescope, which is primarily devoted for exoplanet science. And there are 3 X-ray missions: the X-ray polarimeter, a spectrometer, and fast timing in X-rays. Ultraviolet missions planned, the spectroscopic survey mission, and for ultraviolet polarimetry. This includes the INSIST and the Daksha projects, which have already been funded with some initial funding to develop, do some prototype development of the technology and proof of the concept technology development. So, what should the future of the Astronomical Society of India be? We should remember that this is the only body of professional astronomers, and the membership of the ASI is one easy source for the number of astronomers in the country. And no, the membership of the ASI and its evolve and how it evolves is actually reflects the projection of the growth and strength of the Indian astronomy in the country. And these are extremely important factors for future projects. So I do know that at present, not all astronomers in the country are members of the ASI. And I urge them to become members. There are several of them attending this meeting, hopefully. I sincerely urge you all to become members because it is very important that the membership in ASI reflects the number of Indian astronomers in the community, because this is what determines the amount of funding that we are going to get for astronomy projects, and the future of astronomy in the country does depend upon this funding and how we show the growth and evolution of the community. This is an extremely important aspect. So ASI should actually be the voice of astronomy in the country, and that is what we should move towards. We will be hearing what the roadmap for the future of astronomy in the country should be in Ajit's public talk, where he'll also talk about the history and the future. And we also plan to have a workshop in October this year, where we'd like to discuss the roadmap for the future of ASI and the Indian astronomy. So with this,
Thank you so much, Professor Anupama, for a very nice presidential lecture, for giving us a brief historical overview of the ASI and also walking us through the Mega Science Vision document, touching upon the ISRO's plan for the future as well, and the encouragement and the urging to the younger members of the audience to actually become members of ASI. Thank you so much. I now invite Professor Sunil Krishnan from IIT Roorkee to present the vote of thanks on behalf of the LOC.
So, thank you, Professor Oberoi. So, on behalf of LOC, it's my pleasure to convey a vote of thanks to all the members of our institute who have helped us in organizing this mega event. So first, I would like to thank Professor Vijaya, Principal Scientific Advisor to the Government of India, for delivering the inaugural address. And I would like to thank Professor Rajiv K. Chaturvedi, our Director, for his constant support and encouragement and various suggestions while planning the event. I would like to thank our Dean of Academic Affairs, Professor Apurva Sharma, and Associate Dean of Academics, Professor Ramchandran, for their support. The office staff of Academic Affairs Office has been particularly helpful in arranging the venues and making the latest digital multimedia equipment available to us. I would also like to thank the office of Professor Umesh Sharma, Dean of Infrastructure, for helping us at various levels, and the support received from our colleagues at Department of Physics and our Head of Department, Professor Verma, is thankfully acknowledged. I thank the office staff of Institute Security, Hospitality, Institute Hospital, Transport, Institute Computer Center, Media Cell for their support and help. Lastly, but most importantly, I would like to thank all the volunteers from IIT Roorkee and ARIES for all the time and energy that they have spent in organizing this event. With these words, I welcome the entire Astronomical Society of India community to IIT Roorkee. I hope you will have a scientifically rewarding time and a pleasant stay in our campus for the next few days. Please join us for high tea arranged just outside the hall. Thank you.
Hello, everyone. So we will reconvene just after the high tea at 11:45. The online participants, please. So we'll probably keep the Zoom session running, but we will start the proceedings again at 11:45. So see you then. Let's be back on time.